Hello, Mr. Ravi. Welcome to YourPedia. Let's start your snap interview on the subject control systems for your PGCL interview preparation, right?
SJVNL.
Oh, SJVN. Okay, fine. So tell me, what is the difference between controller and compensator, Ravi?
So controller is we can say controller is a device and compensator is an algorithm we design for actually. Means we go for controller because we have to reduce the error. But is there any parameter variation or anything else or like stability issue, gain margin, phase margin, we go with the compensator.
So which controller is used to reduce the steady state error?
PI controller.
Yeah. How it is going to reduce steady state error? Can you brief?
Sir, it will add an extra pole at the origin.
With that,
And
what it is going to happen?
with P controller, actually we increase the speed of the response. And let's suppose I will take a first order system. Let's say k by tau s plus one, and let's I add a pole in this region. It will integrate the error actually. Let's take an example of a let's suppose a water tank. It is a 60% water our aim is to maintain, but there is a reduce of water to 40 level 40 liter. So there is a error of 20 liter that can be integrated by this PI controller, and that will fit into the controller, and it will reduce the error.
Okay. What are the problems we face with the Routh-Hurwitz criteria?
Sir, if you see the characteristic equations, uh, is this criteria only gives us the stability of absolute stability, and for the characteristic equation only algebraic and of real coefficients. It is not valid for our exponential and other logarithm type of input coefficients or these all. And second thing, that not gives you the exact locations of the poles.
Then how to overcome all these disadvantages of Routh-Hurwitz?
Sir, we can go for uh, frequency domain. We can go for Nyquist stability, where the absolute and relative stability both we can be uh, solved. Means
Can you explain Nyquist stability criteria? Can you explain Nyquist stability criteria?
it is the stability of a closed loop system from open loop transfer from the open loop uh, transfer function like GSHS, and it's said that the stability when the of let's suppose we have a GFHS, and it gives the number of encirclement around -1 plus J0 point uh, anti-clockwise as number of poles in the right hand side of the uh, frequency domain GSHS, means open loop system.
Fine. Okay. What is the purpose of Bode plot?
Border plots for the we have to identify any parameter variation that easily done by the border plot because it is a approximation and approximate plot of different asymptotic type plot, and it is a logarithmic plot so that we can easily means it is wide range of frequency can be covered. And secondly, any kind of subsystem if we are that can be easily also very that easily visible by this. These are a kind of a linear plot, sir. So any kind of disturbance noise already can be identified by this. Any variation also can be easily identified this.
Okay. What are the problems, disadvantages with border plot?
I'm not able to recall, sir.
Border plot is applicable only for minimum phase systems, man. For non-minimum phase systems, border plot is not applicable. That is the main disadvantage. Got my point?
Yes, sir.
Okay. Right. Okay. See, थोड़ा इम्प्रूवमेंट की जरूरत है रविकांता. इट्स ओके, योर कंट्रोल सिस्टम इज अप टू मार्क. आपको बॉर्डर प्लॉट का डिसएडवांटेज नहीं पता है तो क्या प्रिपरेशन किया है. और एसवीजीएनएल में कंट्रोल सिस्टम की इतना इंपॉर्टेंस नहीं है. मोस्टली क्वेश्चंस विल कम फ्रॉम machines, power system, power electronics, measurements. Control system, if at all they want to ask, they will ask questions mostly from controller and compensator. Okay?
Okay, sir. Tomorrow I will again read the control system and power electronics both, sir. I will give an.
Okay, fine. Okay.
Sir,